Hello and welcome to day one of pre-calc. Today our objective is going to be to understand and use the terms domain, range, independent and dependent variable, and asymptote to describe mathematical situations. Let's start out by just defining a few of these terms. An independent variable is a variable that we get to change or manipulate. We call it input, what we input to a function. A dependent variable depends on the independent. So we call this one the output. So a quick example, if you think about getting a job, the hours you work is your independent variable because you get to choose those hours, whereas your pay would be the dependent variable because however many hours you work, that will affect your pay. So the more hours you work, the more you get paid kind of deal. Domain and range take these two terms and basically just look at them in terms of graphs and functions and tables. And so our domain is usually, or is our x values. So all the values that we can put into a function or equation that makes sense. Where our range are our y values. So after you put all of these x values into the function or graph or table, what are your resulting y values? So let's just look at a few graphs and figure out what the domain and range are. All right, so we are going to use interval notation generally when we're talking about writing our domain and range. So if I'm looking for domain, I'm looking for what x values are taken on by this graph. So I start by looking at this is the first x value that is taken on, and that is 1, 2, 3, 4, 5, negative 5. Then all of these x values in here are all taken on by the graph, and we end at 1. So the domain of this function would be negative 5 to 1. Now there's a couple things we also have to talk about when we talk about how am I going to write this. The big thing is with interval notation, we use parentheses if we do not include, and we use brackets if we do include the endpoints. So looking at this graph, I am including these endpoints, so therefore I should use brackets. Now some people could also maybe write this as an inequality and write it as less than or equal to, negative 5 is less than or equal to x, which is less than or equal to 1. And again using the equal signs because it actually counts those points. Whereas if we're talking about our range now, our range we know we're looking at our y values. So your y along this line, which y values are taken on? Well, the smallest y is right here, which happens to be negative 2. And the biggest y happens to be right here, which happens to be 1, 2, 3, 4, 5, 6. So we have negative 2, comma, 6. You always start with the lowest number. And then you ask yourself, am I including these points or not? And if you include them, you use brackets. And again, if I'm writing in interval notation, that the brackets, if I write in inequalities, I would write less than or equal to y, which is less than or equal to 6. All right, let's look at another example. All right, so now we have a couple different things. We have an open circle, and we have array. That goes on forever. So when I'm looking at the domain of this function, I want to say, okay, where does the x start? Well, 1, 2, 3, 4, it gets really, really close to negative 4. But since there's a circle there, it doesn't include it. And if we remember, if you don't include it, you use a parenthesis. And then you see where does it go on. And don't stop at 1, 2, 3, 4, 5, because that arrow means it goes on forever. So we use infinity to represent forever. And you also never include infinity. Infinity is an idea, not a number, so you can't ever include it. So it's always a parenthesis. And if you are writing in inequality notation, you would write strictly x is greater than -4. Now looking at the range, what is the smallest y value taken on by this graph? And again, it looks like it gets really, really close to -2, but does not include -2. And then if you look at the y values are just going to increase forever. So again, it's going to go up without bound. And so we use parentheses on both ends. And if we're using inequality notation, we would write strictly y is greater than -2. So either one of, you can either write that or you can write that. You don't need to write both of them. All right, last example. We have an asymptote in this example, and an asymptote is just a line here in the dotted red line that your graph approaches but doesn't reach. So when I look at the domain, I can say, okay, well, all of these x values from here are being taken on up to 2. So these are from -infinity to 2. All right, and then beyond 2, it looks like everything's being taken on 2, 3, 4, 5, 6. But again, you see the 6 is not included. And 2 is an asymptote, so we can't include that one either. And then it looks like the values between 6 and 7 are. And what we do to combine all three of these is we put them next to each other, and in the middle we write little union signs. I'm kind of running out of space here for my union signs. And what I mean by union signs are basically little U's. U, U. Let me grab that parenthesis right there. All right, and now let's look at the range. What does the range go between? The range looks like it goes, because of this asymptote, it will go all the way to positive infinity. It will go all the way to negative infinity. So the only area you have to worry about with the range is that area right there, because it doesn't ever hit that. So that looks like that's between 2 and 3. So the range looks like it goes from negative infinity to 2. It looks like it actually hits 2, so I'm going to include 2. And then union 3, and it looks like it includes 3 to infinity. All right, hopefully that explains domain and range. And you are welcome to do this problem on your own, and we will go through it in class tomorrow. All right, have a nice day.